In today's session, we start with the capacitors part. Here, first question goes like this. Two capacitors, 6 microfarad, 100 volt and 4 microfarad, 100 volt are connected in series. The capacitance and breakdown voltage of the combination will be. Here, we must first learn what is breakdown voltage. Breakdown voltage means the maximum voltage to which it can be charged. In fact, here observe, we are connecting them in series. That means first we calculate effective capacitance in series. Series effective capacitance will be CS equals C1 C2 by C1 plus C2. That is 6 into 4 by 6 plus 4, which is 22.4 microfarads. Therefore, any one of the option 2 and 3 is correct. But observe, they are in series, voltages get added. Therefore, 100 and 200 volts. So, new breakdown voltage will be 200 volt. Therefore, option 3 is correct. A parallel plate air capacitor has a capacitance C. When it is half filled with a dielectric of dielectric constant phi, the percentage increased in the capacitance will be. So for this, we calculate the new capacitance by using the formula C dash. C dash is equal to 2K1 K2 by K1 plus K2. Here I take K1 as 1 for dielectric medium air, K2 as 5 and K1 1 plus 5 whole into C, because the original capacitance C epsilon naught A by D is to be taken. Now it is 10 by 6 or 5 by 3 C. Therefore, the percentage increase in the capacitance is C dash minus C by C into 100, which is equal to 5 by 3 minus 1 into 100, which is 2 by 3 into 100, which amounts to be 66.6%. So, fourth option is correct. Going for the third question here, we read, two identical capacitors, each of capacitance 5 microfarad, are charged to potential 2 kilovolt and 1 kilovolt respectively. The negative ends are connected together. When positive ends are also connected together, the loss of energy of the system. Observe here, we have to calculate energy initially stored and then energy after connection. And then we have to subtract them. So first we calculate initial kinetic energy, initial energy stored in the capacitor. So UI is half C1 V1 square plus half C2 V2 square, half C1 5 micro V1 square 2 into 10 raised to 3 whole square plus half C2 5 micro into 1 into 10 raised to 3 whole square. Now this amounts to be, say, micro 10 raised to 3 square cancels. What we have is 1 by 2 taken out, 2 square 4, 5 into 4 20 plus here 1 square 1 5, which amounts to be 12.5 say 12.5 joules. Now, in the same manner, UF, that is 5, to calculate the final energy stored, we have to take the formula half C effective Vc square. Vc is the common potential and C effective is the effective capacitance. C effective, as they are in parallel, is 5 plus 5, 10 microfarad common potential Vc is C1V1 plus C2V2 by C1 plus C2, which amounts to be 5 common 10 raised to minus 6 into V1 plus V2, 1 10 raised to 3 plus 2 into 10 raised to 3 divided by 10 into 10 raised to minus 6. So cancel these things. What we left is 5 2s are, therefore 3 in the numerator, 3 by 2 into 10 raised to 3, that is 1500 volts. Now we know Vc, we know C effective, therefore final potential energy UF is half C effective is 10 into 10 raised to minus 6 into Vc square 1500 whole square. So which we simplify as 10 raised to minus 6. This can be written as 2.25 10 raised to plus 6. This goes there. Therefore, what we left is 5 into 2.25, which amounts to be 25. 5 2s are 10 plus 2 12. So 11.25 joules. Therefore, loss of energy delta U is UF minus UI 11.25 minus 12.5. So minus 1.25 joules. So option 2 is correct. Option 2 is correct. Next, going on to the fourth problem. Here I can get you a simple formula for the effective capacitance calculation like this. C dash is equal to K1 minus K2 into N plus K2 into C, where N is the fraction of the area filled by the dielectric. Now we apply all the things. Here N is given to be, we read, a slab of dielectric constant K and having same thickness as the separation between the plates is introduced so that it fill 1/4. N is 1/4 of the capacitance, 1/4 of the gap. The new capacitance, we substitute everything here. C dash with K1 as K, K2 as 1 now. So K minus 1 into 1 by 4 plus 1 into C. Now we have K by 4 minus 1 by 4 plus 1. So into C. K by 4 plus 3 by 4 into C. Therefore, answer is K plus 3 into C by 4. The third option is correct. K plus 3 C by 4. So this is a shortcut formula, the final formula what you can take, where N is the fraction of the area filled by with a dielectric of K1. N is the fraction of area filled by the dielectric of constant K1. Other medium is taken as air. Now, fifth question. 2 microfarad capacitor is charged to a 200 volt and then the plates of the capacitor are connected to a resistance 10 kilo ohms. The energy dissipated is directly half CV square. We do this. Half C is 2 into 10 raised to minus 6 into V square 4 into 10 raised to 4. So which amounts to be 4 into 10 raised to minus 2 joules. So option 2 is correct. Now here is slightly different problem. We read it. Energy of a charged capacitor is E. If it is allowed to share its charge with another identical capacitor charged to half its potential, loss in the energy of the system. So, Ui given to be E here. And then we are going to allow it to share the charge with another identical capacitor with uncharged capacitor, or charged to the of its potential. Therefore, now what we do, we calculate the common potential after connection. Vc is C1 V1 plus C2 V2 by C1 plus C2. C1 and C2 are same, as they are identical capacitors. C I take. Then V1 plus V2, V plus V by 2, half the potential it is charged, divided by 2C. So cancel it. We get 3V by 4. Therefore, common potential is known and C effective is C plus C, 2C after connection. Therefore, so the UF final energy is half C effective Vc square, half 2C. Vc square is 9 by 16 V square. Therefore, 2 cancels here, 9 by 8 I can write half CV square, which is 9 by 8 E. As E is initial energy, what I can write as half CV square. Therefore, finally, the loss in energy is UF minus UI, which amounts to be 9 by 8 E minus E, that is 1 by 8 E. Option number 3 is correct. Option number 3 is correct. Say, going over to the 7th question. It's a simple question, but a important logic to be learned here, a trick to be learned here. Observe, these things are connected by wires. In fact, any two terminals in the circuit, in any circuit, connected by a wire, are taken as one and the same. That means if I take this as A, this is A. And if I take this as C, this is also C. In the same manner, this is connected, this is also C. This is connected, so this is B. Observe here, in this first part, in this off, all the three, this is C1 if you want, C2, C3, are connected in parallel between same 2 points, AC, AC, AC. Therefore, all these three, C1, C2, C3 are connected between same 2 points, AC. Therefore, they must be in parallel. Therefore, this overall thing amounts to be 3C capacitors. On the same grounds, C4, C5, C6 are also in parallel. These three again in parallel. Therefore, 3C, 3C effective capacitors. But these two 3C, 3C will be in series later. Therefore, effective capacitance of the combination 3C by 2, as C by N is the effective capacitance with N identical capacitors in series. Therefore, 1.5 C. Option 4 is correct. So, this is the option 4. Going for 8th question. When an additional charge 2 coulomb is given to a capacitor, energy stored in it increased by 21%. The original charge on the capacitor, say we take Q1 as the initial charge and energy is U1. Q2, which is equal to Q1 plus 2 coulomb, and final energy as U2. And observe, you know formula half Q square by C as the energy formula. As C remains constant, we can say U proportional to Q square. And also percentage change percentage change in energy formula is delta U is U2 minus U1 by U1 or U2 by U1 minus 1 into 100. Only change is this much. Percentage change means delta U into 100. Now, say, as we know U is proportional to Q square, I write U2 by U1 as Q plus 2 by Q1 whole square. Therefore, substituting for delta U now, delta U into 100 is given to be 21%. Therefore, this I write as 0.21 is equal to U2 by U1 minus 1, which is 1.21 U2 by U1, which is Q plus 2 by Q whole square. Therefore, Q plus 2 by Q is 1.1 after taking the square root of 1.21, which is 1.1. Q plus 2 is 1.1 Q. Therefore, Q equals 2 by 0.1, which amounts to be 20 coulomb. So, fourth option is correct. Next, going over to the ninth question. A region between parallel plates of a capacitor is filled with parallel layers of air and paper. The space between the plates is 1 millimeter and thickness of paper is 0.75 millimeter. The ratio of the voltages across the pairs of the across air and paper plate capacitors. Say, the diagram may be written like this. This is 1 millimeter and paper is filled up to 0.75 millimeter. This is with K4. This is air, K1. Now in this type of case, we are asked to calculate the potential. If I write C as epsilon naught A by D, for the K dielectric capacitor, this is C1, I can write C1 as K epsilon naught A by 3 D by 4 as 0.75 millimeters, 1 and 3/4 of the 1 millimeter plus. C1 is like that. In the same manner, C2, epsilon naught A by D by 4 as remaining distance is 0.25, 1 by 4. Now, they are all in series, or this I can write as 4 by 3 K epsilon naught A by D, which I can write as 4 by 3 into 4 into C, that is 16 by 3 into C, here 4C only. Therefore, the ratio of the voltages to be calculated, therefore, we know the charge remains same. Charge on both, as they are considered as series, Q1 is equal to Q2. Q1 is written as 16 by 3 C V1, which is equal to Q2 written as Q2 4C into V2. Therefore, air to paper is asked. Air is V2, V2 by V1. This is 4 4s are 16. Therefore, V2 by V1. Because V2 is for air capacitor, V1 is for the paper capacitor, V2 by V1 is asked. air and paper is asked. Therefore, V2 by V1 is 4 by 3 volts. Therefore, option 3 is correct. Option 3 is correct. Now going over to the 10th question. It is also simple. We read. A voltmeter reads 4 volts connected to a parallel plate capacitor with air as dielectric. When a dielectric slab is introduced between the plates for the same configuration, voltmeter reads 2 volts. What is the dielectric constant of the medium? Very simple idea. V equals C into V to be used. We use it like this. 4 volts can be written as C air say we write 4 volts as Q by C air. Q is the charge on the capacitor. In the same manner, 2 volts can be written as the charge remains same because same configuration, K into C air. Now going for the division, we get 4 by 2 as K. Therefore, K equals 2. Option 2 is correct. Going for the 11th question. It's a very simple question and very important trick will be learned here. Observe in this circuit. If I take this as the midpoint, then this acts like a Wheatstone network configuration. Say this is capacitor and another capacitor here. I call that, for that matter, this as C and D. Now this is A, C and B. Here I write like this. C and B like this. And this 4 is connected between C and D, which we can take like this. But observe, all the 4 arms are having 4 and 4. Middle one is also 4, but it's a balanced Wheatstone network in which we know the intermediate thing, that is C to D connected, is not required. There's no potential difference across it, and therefore, and effective capacitance, we also know when all the 4 arms are same, effective capacitance is same as that of 1 arm. Therefore, 4 microfarad is the effective capacitance. Option 1 is correct. Option 1 is correct. Now, 12th question we read. A capacitor of capacitance C charged by an amount Q is connected in parallel with an uncharged capacitor 2C. The final charges on the capacitors are, say, first one capacitor is charged to Q, second capacitor is uncharged. We are asked to calculate the final charges on the capacitor when they are connected in parallel. Therefore, net charge on the capacitors is Q, before connection or after connection. And we calculate common potential, Q net charge divided by C plus 2C. That means Q net by 3C is the common potential. Once we know the common potential, we can calculate charges on individual capacitors. Here Q net is nothing but Q by 3C because Q net is Q. Now, potential on one capacitor C, the final charges on one capacitor is Q1 I say on C, Q1 I say C1 VC. C1 VC is C Q by 3C. C cancels Q by 3. Therefore, another will be definitely 2Q by 3 because Q by 3 is having only one option. Therefore, fourth option is correct. Now, going for the 13th question here, we have two air capacitors 1 microfarad and 4 microfarad connected in series with 35 volts source. When a medium of dielectric constant K equals 3 is introduced, between the plates of A, charge on capacitors changes by, say, now first we calculate effective capacitance. As they are in series, CA CB by CA plus CB is our formula. Say 1 into 4 by 1 plus 4 micro, that is 4 by 5 microfarads is the effective capacitance. Therefore, net charge on each capacitor now is, say, C effective into V, 4 by 5 into 35, so 28 microcoulomb is the net charge in the combination, either on A or on B. Both have 28 microcoulomb because they are in series. Now, when a medium of dielectric constant K equals 3 is introduced between the plates of a capacitor A, charge on the capacitor will be, now we calculate effective capacitance when dielectric medium is introduced. Then C effective dash equals CA dash CB by CA dash plus CB. CA dash is 3 times A, that is 3 micro into 4 micro divided by 3 plus 4 micro. Therefore, 12 by 7 micro. Therefore, now the new charge Q dash on either of the capacitors is C effective dash into V. 12 by 7 into V is 35. 7 5s are, so 60 microcoulomb. Observe, we are asked to calculate charge on the capacitors changes by change to be calculated. Originally, it was 28 microcoulomb. Now it is 60. Therefore, change is Q dash minus Q. 60 minus 28, which is 32 microcoulomb. Option 1 is correct. 1 is correct. Going for the 14th question here. 3 identical capacitors are first connected in series and then in parallel. The ratio of the effective capacitance is in 2 cases. That is, CS we know, when identical capacitors are connected, C by N, that is here C by 3. In parallel combination, 3C. Therefore, CS by CP is C by 3 by 3C, which is 1 by 9. So, 4th option is correct. Now going for the 15th. For a polar molecule, which of the following statements is true? The center of gravity of the electrons and protons coincide. It is wrong, because if they coincide, they cannot be polar. The center of gravity of electrons and protons do not coincide. It is correct. That's why they are polar. Therefore, option 2 is correct. Next, going over to the 16th question. A parallel plate capacitor is charged and then isolated. Observe, they are charged, that is charged and separated from the battery. It is not connected to battery. The effect of increasing the separation, plate separation on charge, potential and capacitance. Say we know parallel plate capacitance area epsilon naught, say expression is epsilon naught A by D. Since we are isolated, we have isolated the capacitance. The capacitance, first thing, charge, potential and capacitance. As that is not connected to battery due to charge conservation, charge should remain constant and capacitance should decrease. Charge should constant, capacitor should decrease. So, in the options first and fourth, among the first and fourth, anyone will do. Now, as the separation is increased, potential should decrease. Therefore, we have option 1 is correct. 17th question, we think of a system of 2 capacitors Capacitance 2 microfarad and 4 microfarad connected in series across potential difference of 6 volts. The electric charge and energy stored in the system are, say first we calculate charge stored. For that we need effective capacitance as they are in series. C effective is 2 into 4 by 2 plus 4, that is 8 by 6 or 4 by 3 microfarads. Once we know C effective, charge can be calculated. C effective into V, 4 by 3 into 6, 3 2s are. So 8 microcoulomb is the charge. Here itself we can decide the answer as third option, 8 microcoulomb, but it is having only one 8 microcoulomb among 4 options. But we also check for energy stored. Energy stored is to be calculated. For that, half CV square we apply. Half C effective into V square. Half C effective is 4 by 3 into V square is 6 square. Observe, say 2 2s are 4, 2 into 36 by 2, 3 12s are, so 24 microjoules. So as we decided, our third option is correct. Now going for the 18th question. Here, if you go for the calculation, it becomes tricky, but it's not required. We read the question carefully. The minimum value of effective capacitance that can be obtained by combining 3 capacitors of capacitance 1, 2 and 4 picofarad. Observe, in series combination we have the smaller than the smallest capacitance. In the parallel, larger than the largest capacitance as the effective capacitance. Say here the smaller than the smallest means less than 1. Now we read all the options. 4 by 7 is definitely less than 1. Second is 1 picofarad, it cannot be equal to. 7 by 4 is also not equal to. 2 is also not less than 1. Therefore, option 1 is correct. Let me tell you once again. As in the series combination, smaller than the least is the effective capacitance. Among 1, 4 and 2, 1 is the least. In the given options, except for first option, all the 3 are more than 1. Therefore, option 1 is correct. Now going for the 19th. A 10 millifarad capacitor has been charged to potential 10 volts. It explodes suddenly. Energy given. U equals half CV square. Straightforward formula. Half into 10 milli into 10 raised to minus 3. 10 into 10 raised to minus 3 volts. V square means 100 square into 100, which amounts to be 2 5s are and 4, 5 into 10 there, 50 joules. So option 1 is correct. Going for the 20th question. In this diagram, potential difference between A and B is 60 volts. The potential difference across 6 microfarad is to be calculated. Observe, it is easy to calculate. We write all the capacitance in a slightly different manner. Observe 3 and these 3, these 2 are in parallel. Therefore, their effective capacitance is 6 microfarad. Now, we have in series 6, say like this, 6 microfarad capacitance. And then I write another 6 microfarad capacitance for parallel combination. These 3 and these 3 are in series. Therefore, I write them separately. In series combination, you can change the portions of the capacitors to any portion. Now looking at these things, say these 2 will have 3 by 2 capacitance, that is 1.5 microfarads. Now we have 6, 6 and 1.5 microfarad. We are asked to calculate the potential difference across 6 microfarad first capacitor. For that, I calculate effective capacitance there, C effective for first 6 and 6 is 3. First 6 and 6 is 3 microfarad by formula C by 2. Therefore, now the circuit is 3 and 3 by 2 microfarads. Therefore, they are in series 3 by 2 by 3 plus 3 by 2, which amounts to be, say, 9 by 9. 2 3 is 6 plus 3, 9. So 1 volt, 1 microfarad is the capacitance. As effective capacitance is 1 microfarad, charge on each capacitor Q is equal to C effective into V. C effective into V. C effective is 1 micro into V is 60 microcoulomb. Therefore, potential across 6 microfarad is V equals Q by C, 60 micro by 6 microfarad. Therefore, you cancel these things, 10 volts. So, option 4 is correct. Option 4 is correct. We start 21st question now. In the circuit below, capacitors A and B have identical geometry, but material of dielectric constant 3 is present between the plates B. The potential difference across A and B are respectively. Here a very simple idea as we did in previous problems also. First we calculate effective capacitance and net charge. Then we go for the potential. That's the easiest one. So now we take CA as C, CB as 3C, because where C is epsilon naught A by D, as that is given, they have identical geometry, means epsilon naught A and D are all same. Therefore, effective capacitance C effective is CA CB by CA plus CB, which is C into 3C divided by C plus 3C, which amounts to be 3 by 4C. C effective is known now. We want to calculate potential difference. So charge, net charge is C effective into potential, 3 by 4C into potential is 10 volts applied. Therefore, 30 by 4 into C is the charge on each capacitor. We are asked to calculate the potential difference. Say potential difference on A, VA, is charge by capacitance CA. Charge is 30 by 4 into C divided by CA is C. Cancel it. 30 by 4. What I can write as 7.5. 4 7s are 28, 4 5s are 20. So 7.5 volts. Another can be easily obtained, 10 minus 7.5, 2.5 volts. Therefore, option 3 is correct. Going for the 22nd question, there a parallel plate air capacitor is charged by connecting its plate to a battery. Without disconnecting the battery, a dielectric is introduced between its plates. As a result, observe, we are not disconnecting it from the battery. That means voltage is kept constant. Now we read all the things. Potential difference between the plates increases. Wrong, because it is connected to battery, it remains same. Charge on the plates decreases. It is impossible. More charges will go to put. So capacitance of the capacitor decreases. It's also impossible. Capacitance has to increase. Therefore, only option possible is 4th, none of this. Going for the 23rd. While a capacitor remains connected to a battery, a dielectric slab is slipped between the plates. The almost same question, but we read all the options. The electric field between the plates increases. It's not the case. It should decrease. Energy stored in the capacitor decreases. It is also not possible. The potential difference between the plates is changed It is not possible. So charges flow from the battery to the capacitor. Definitely it is the correct one because all the three are not possible. Going for the 24th question. 125 water drops of equal radius and equal capacitance coalesce to form a single big drop C dash. The relation between C and C dash. Observe what you are not learnt in NCERT syllabus or NCERT book. Capacitance of a parallel spherical conductor is 4 pi epsilon naught R to be used here. Therefore, for small drop C small, what is given to be C? I write 4 pi epsilon naught R. And for big drop, combined drop, CB I write 4 pi epsilon naught R. But we know when drops combine, the radius of the bigger drop is n to the power of 1 by 3 R. Therefore, CB can be written as 4 pi epsilon naught R into n to the power of 1 by 3 or simply n to the power of 1 by 3 into C. In their notation, C dash equals n to the power of 1 by 3 C, but n 125 drops are given. What I can write as 5 cube. Therefore, C dash is 5 cube whole to the power of 1 by 3 C. Cancel it, 5C. So, option 4 is correct. Next, going over to the 25th question. It's a combination question again. In the electric circuit given below, capacitance of each capacitor is 1 microfarad. The effective capacitance between points A and B. Observe again here. This can be treated as a effect Wheatstone network also. I write the circuit in this manner. This is A. If we want, we name the capacitors. Observe, this is our C6, this is our C1, C2, C3, C4, C5. As this is a Wheatstone's network combination without anything there, directly we can take the combination effective capacitance as 1 microfarad only. As C1, C2, C3 are all 1 microfarad, it is 1 microfarad. And C6 is also 1 microfarad. C1 is 1 microfarad. Therefore, final combination will be like this. Say this is 1 microfarad, this is 1 microfarad, this is 1 micro, this is B and this is A. These two are in parallel. So, which amounts to be 2 microfarad. 2 and 1 are in series. Therefore, C effective is 2 into 1 by 2 plus 1, 2 by 3 microfarads. So, option 2 is correct. Option 2 is correct. Now, going for 26th question. We read, when a potential difference of 10 raised to 3 volts is applied between A and B, a charge of 0.75 millicoulomb is stored in the system of capacitors. That means we are applying between A and B 10 raised to 3 volts. Say here 10 raised to 3 volts applied. And charge in the system Q net is given to be 0.75 milli 10 raised to minus 3 coulomb. What we can write as 3 by 4 millicoulomb for easy calculations. Now observe, these two are in series, these two are in series. Therefore, we can write the circuit after a little bit of simplification. 10 raised to 3 volts. This is 1 microfarad now because this amounts to be as series, half of that will be there. So 1 microfarad. Now this is also 1 microfarad as they are again in series. Effective capacitance 1 micro and C can be connected between these two as this point and this point are one and the same. This is our B now. This is C. These two are in parallel, so C plus 1. Therefore, effective capacitance of the circuit is now simply 1 and C plus 1 series. C plus 1, 1. So 1 C plus 1 into 1 by C plus 1 plus 1, that is C plus 1 by C plus 2. Effective capacitance. What is that we are asked to calculate? We are given the charge in the system potential. So we are asked to calculate the C value. Therefore, total charge is given 0.75 millicoulomb. We write total charge is given and C effective is given. Voltage is given. So Q is equal to C effective into voltage. Q is 3 by 4 into 10 raised to minus 3 coulomb. C effective, C plus 1 by C plus 2 into V 1000, 10 raised to 3. Now we simplify it like this. Say if I write it like this, 10 raised to minus 6, C plus 1 by C plus 2. For the sake of clarity, 10 raised to minus 6 we can leave because final answer will be in microfarad. I can take simply 3 by 4, C plus 1 by C plus 2. Now the C value what I get will be number which is in microfarads. We cross multiply 3, 6, 4C plus 4. Therefore, C equals 6 minus 4, 2. So option 3 is correct. 2 microfarads. Option 3 is correct. Going for next question. It also doesn't require any calculation. We can straight away calculate. We see the equivalent capacitance of three capacitors of capacitance C1, C2 and C3 connected in parallel is 12 units and product is C1, C2, C3 48. When capacitor C1, C2 connected in parallel, equivalent capacitance is 6 units. Then the capacitance, we are given C1 plus C2 plus C3 12. C1, C2, C3 48. It is just a matter of looking into 4 options in which these 2 conditions satisfy. You need not bother about the third condition, that's not required for the time being. Say in all the cases, the sum will be 12 except for 2, second option. But in which it is 48 we check. Say in the first 3 it is not 48 because in the third 7 plus say 7 3s are 21 plus 21 into 2 42. It's not possible. Likewise in all the things. Only fourth option is having both the conditions satisfied. So answer option 4 is right. Now 2 capacitors with capacitance C1 and C2 are charged to potentials V1 and V2 respectively. When they are connected in parallel, the ratio of their respective charges. Say again, we write simply the common potential. We write common potential and net charge and finally we come back. VC is C1 V1 plus C2 V2 by C1 plus C2. This is the common potential. When they are connected in parallel, ratio of their respective charges. So this is VC. There's no need to calculate. We simply write after connection Q1 by Q2 is C1 VC, C2 VC. As VC is same, C1 by C2. Option 3 is right. So option 3 is correct. Going for the 29th question. In a parallel plate capacitor of capacitance C, a metal sheet is inserted between the parallel plates parallel to them. The thickness of the sheet is half. The separation between the plates, the capacitance now becomes. It's also a very simple idea now. Just observe. I write first air capacitance with the separation D. Now we fill up the half of the gap with metal sheet. That means you can fill it up anywhere. For easy calculation, I've connected to the bottom plate there. This is D by 2. Therefore, as it is a metal plate, it is as good as shifting the bottom plate to this level. This separation now d by 2 only. This part will not contribute anything to the capacitor because it is a metal sheet. Therefore, now the new capacitance C dash, the original capacitance is C epsilon naught A by D. Now the new capacitance C dash is epsilon naught A by D by 2, which is 2 epsilon naught A by D, which amounts to be 2C. So option 4 is correct. Now going over here, 30th question. Observe. In this figure, we are asked to calculate effective capacitance between A and B. These two microfarad capacitors are in parallel. Therefore, they amount to be 4 only. Again, we write the circuit like this: 4, 4, 4. And this is AB. Again, observe, there is one more Wheatstone's network circuit. All the things are 4. Effective capacitance is 4 microfarad. Option 2 is correct. Option 2 is correct. Going for the next question, we read. Two capacitors of capacitance 3 microfarad and 6 microfarad are charged to potential 12 volt. They are now connected each other with the positive plate of the each is joined to negative plate of the other. Observe, positive plate now connected to negative plate. The potential difference across each will be here also. First we calculate the common potential and net charge and we go for the calculation. We are asked to calculate the potential difference. So first thing, we calculate C effective. C effective, as they are connected in parallel, 6 plus 3, 9 microfarad. Now, they are charged with 12 volts. So we go for the initial charge, that is net charge, after connecting them in parallel. The common potential to be calculated, that is 12 volts. We go for charge on the capacitors, net charge in the combination. So Q1 on C1 is C1 into V, 3 into 12, 36 microcoulomb. Q2 C2 into V, 6 into 12, 72 microcoulomb. But observe, as we are connecting positive to negative, net charge in the combination now, Q2 minus Q1 as negative to positive connected, 72 minus 36, 36 microcoulomb. Net charge is 36 microcoulomb. Effective capacitance is 9 microfarad. So potential difference, V equals Q by C. Q by C effective. Q is now 36 micro by C effective is 9 micro. So 4 volts is the answer. So second option is correct option. Going for the 32nd question, it's again a Wheatstone network combination. Effective capacitance between A and B in the figure, say it is all there. All capacitance are in microfarad. Observe here, now the capacitance are not same. We first check in this type of thing whether the network is balanced or not. I call this as C1, C2, C3, C4. First I take C1 by C2, 3 by 6, that is half. Then C3 by C4, which is 4 by 8, 1 by 2. Therefore, C1 by C2 is same as C3 by C4. Network is balanced. Network is balanced. Therefore, we can apply the condition for balance and 2 microfarad can be eliminated. Now, very simple circuit, it becomes like this. Say this is our C1, C2, C3, C4. These two are in series. That means 6 into 3 by 6 plus 3, which is 18 by 9, 2 microfarads. And this is again 8 into 4 by 8 plus 4, 32 by 12. You can do it as 4 8s are 4 3s are 8 by 3 microfarads. Now we have the things, two things. So C effective of the complete network is they are in parallel now. 2 plus 8 by 3 microfarads. We sum them. 14. 3 2s are 6 plus 8, 14 by 3 microfarads. So option 2 is correct now. Option 2 is correct. Going for the next question, 33 question number. Two capacitors of capacitor 5 and 10 are connected in series across 90 volt. Energy stored in 10 picofarad. Now, which is also energy stored in particular combination capacitor is asked. Therefore, again we do common potential first and then charge and energy stored. Observe common potential. C, they are connected in series. So C effective will be 5 into 10 by 5 plus 10, that is 50 by 15 picofarad. C effective is known. Therefore, net charge in the combination CQ equals C effective by into V, 50 by 15 into V is 90, 15 6 so 300 picocoulomb. Pico is 10 raised to minus 12. Once you know the volt charge, you require to calculate the energy. As charge is same on both the capacitors as they are in series, the energy U on 10 picofarad capacitor is U equals half 10 raised to minus 12, half, we use the formula U equals half Q square by C. Formula half into Q square is 300 into 300 into 10 raised to minus 12 into 10 raised to minus 12 divided by C, 10 into 10 raised to minus 12. We cancel these things. Now we get half into, so we simplify the things. Observe 9, here itself we can decide. 9 of 9 will be there, 10 raised to 4 by 10 into 10 raised to minus 12. This is 4.5 there. Now the thing is 4.5. This is, say, this one becomes minus 13 plus 4 or 10 raised to minus 9. Therefore, we simplify or simply write and have written it as microcoulomb. So option 2 is correct. Going for the next question, 34th. A number of capacitors labeled as 8 microfarad 250 volts are given. Minimum number of capacitors needed to get an arrangement equivalent to 10 microfarad 1000 volts. Observe, in this type of questions, first we need to look into the breakdown voltage required. Here is 250, here is 1000. That means breakdown voltage required is 1000 out of 250 volts capacitors. So now first we calculate number of capacitors required to get 1000 volts. So that means 1000 volts by 250 will give us 4. That means N, the number of capacitors to be connected in series to get 1000 volts is 4. That means I connect like this. 4 in series. 8, 8, 8, 8. And effective breakdown voltage is 1000 volts. So we achieved the 1000 volts. But the effective capacitance, C effective dash, is 8 by 4, which is 2 microfarad only. But what we require is 10. So this 10 microfarad tells us how many combinations of this type has to be done in parallel, because we know in parallel combination Cp equals Nc. Therefore, Cp equals N into C effective series. That is N into 2 micro, say we call it as N dash into 2 micro, and Cp required is 10 micro. Therefore, N dash is 5. That means 5 this type of combinations to be kept. That means 1 like this you are supposed to write 5, connect 5 combinations. 1, 2, this is 5th one, which are connected in parallel like this will result in 10 microfarad. Therefore, 4 into 5 there, 20 capacitors are required. So option 2 is correct. The next question to be learned here is, capacitance of parallel plate capacitor becomes 4 by 3 times its original value if a dielectric slab of thickness d by 2 they inserted between the plates. D is separation between the plates. The dielectric constant of the slab. Say once partially the gap between the plates is filled with some other dielectric and remaining gap is left with air, we can straight away use the formula what we already used. Say C dash is equal to T into 1 minus K, where C equals epsilon naught A by D. Now, we are given when we insert a dielectric slab of thickness T, T is given, say thickness, and K is to be calculated, but C dash is given 4 by 3 times C, the original value is C, epsilon naught A by D. Therefore, I substitute everything. 4 by 3 C equals K D C divided by KD, and also thickness has been given D by 2, that also we substitute here, plus D by 2 into 1 minus K. Also here all the D's get cancelled and C get cancelled. What I left is 4 by 3 K by K plus half minus K by 2. After simplifying, I will get say 4 by 3 K by 2 plus half, that amounts to be 2K by K plus 1. Now we multiply 4K plus 4 equals 6K. Now you will transfer this onto this side. It is 2K, K equals 2. Therefore, dielectric constant is 2. Option 1 is correct. So this ends our capacitance CET part. Now in the essay almost we completed the electrostatic part as far as CET exams are concerned, and a little bit of NEET, not with the JEE mains. And remember to learn these things by practice, and practice as many problems as you get in the reference books. And also we solved many of these problems in the regular classroom program previously. Now in the next coming sessions we start with moving charges and magnetism and current, electricity and all those things. So most probably in the tomorrow's session we start with current, electricity class up to Kirchhoff's laws.